So we're going to start a new topic, and that's on permutations and combinations. And we'll begin by introducing the factorial function. But first, let us define what combinations and permutations are. So this is a topic that concerns the selection and arrangement of objects, and this will be large numbers of objects typically. So a permutation so both permutations and combinations appear in a wide variety of different settings, and sometimes often very, very important settings. For example, transport logistics, or in biology, the relationships between proteins and genetic engineering. Also, the sorting of algorithms in computer science, and they are used in the protecting of computer passwords and e-commerce transactions using cryptography. So this area of mathematics is hugely important and relevant in our modern age. So a selection of objects is called a combination. It is called a combination if the order of the selection doesn't matter. So combinations are when the order of selection, that's how you spell selection, doesn't matter. And a permutation is when it does matter, when the order so a combination is a way of just selecting orders in any combination. So if you've got the letters A, B and C, then if you were to select these three letters, you can select them in any order. So you'd have A and B, or A and C, or B and C. But if you were wanting to order them in a particular way, like join two, if you were making choosing two letters of A, B, and C, and you wanted them to be joined together, so you could have A, B, B, A, C, A, C, A, B, C, and C, B. There's 6 permutations, because the order in which you select them actually matters. So you can see how this would play an important role in things like cryptography, where order does matter and you're dealing with large sets of data. Now, before we start going into some of the maths with permutations and combinations, we need to introduce the factorial function. This is probably something that you've already come across. So the factorial function is a way of multiplying numbers. So say you have 4 times 3 times 2 times 1. This is called 4 factorial. And it's written as 4 with an exclamation mark. On the calculator you might have a little button that has either an N with an exclamation mark, or it might be written as an X with an exclamation mark, and that's the factorial button. So you would type in your number and push whichever button you have on your calculator, and it'll do that for you. So you don't have to plug in all those digits, which is fine if it's just 4 times 3 times 2 times 1, but if it's something like a bit bigger, it would get very tedious. So what is interesting and probably quite obvious about factorial functions, they can give you very big numbers very, very quickly. So let's look at 7 factorial. So that would just be 7 times 6, oops, times 5, times 3, I've got 4, times 4, times 3, times 2, times 1, my pen's not working well. And if you plug that in, you get 5,040. Now what if you had something like this? 6 factorial divided by 4 factorial. Let's look at what this actually shows us. So we have 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. If you look here, the 4s, the 3s, the 2s and the 1s all cancel, so that just is 6 times 5, which is 30. Similarly, if we had 5 factorial minus 4 factorial, well, this is, we can use algebra here. 4 factorial is 5 minus 1, which is 4 factorial times 4, which is 96. And if you have 3 factorial over 0 factorial, 3 times 2 times 1 over 1, because 0 factorial is actually 1, and that equals 6. So in general, n factorial is equal to, wait a minute, I'll write that again. N factorial is n times n minus 1 times n minus 2 times n minus 3, so on and so forth, until you get to 3, 2, 1. And that's for any integer where n is greater, any integer for n greater than 0, and as I said above, 0 factorial equals 1. So I hope that helps.